Hello and welcome back to the series of Machine Learning with Python. I am Shruti and I am your instructor for this course. So today we are going to cover the k nearest neighbors, the theoretical concepts of k nearest neighbor as well as some practical implementation part of k nearest neighbor. So without any delay, let's begin.
So here we have next algorithm, that is KNN. So there is one proverb, that is birds of feather flock together. So that means same things remain in a common group, and I don't know whether this proverb has its origin, but the algorithm we are going to get introduced has some sort of similarity with this proverb. It is the k nearest neighbor, or say KNN. So KNN is a simple and widely used machine learning algorithm which is based on the similarity measures of the data. So that is, it assumes a data point to be a member of specific class to which it most close. So here we will learn about your k nearest neighbor algorithm. Then we will implement this algorithm in case of your Python. So k nearest neighbor is your non-parametric lazy learning algorithm used for both classification as well as regression. So KNN stores all available cases of classifies new cases based on the similarity measures. So the KNN algorithm assumes that the similar things exist in close proximity. So in other words, say similar things are near to each other. When a new situation occurs, it scan that all past experiences and look up the k closest experience point. Okay, so it measures the neighbors using some distance function, popularly say your Euclidean distance. So the majority of the things, those nearest neighbor will determine the class of new instance of the data. That is, the instance will repeat the category or class of the majority of your neighbor data. So let's assume here the example of your KNN. So suppose we have an image of a creature that looks similar here. Let's say a peacock and your parrot, but we want to know either of this, it is a peacock, this input as a peacock, or say your parrot. So for this identification, we can use a KNN algorithm as it works on similarity measures. So our KNN model will find the similar features of the new dataset to the say your peacock and your parrot images, and based on the most similar feature it will put it into the either the parrot category or say your peacock category. Okay, so here the input is this image, it compares the result and it will put it into the parrot category and shows you an output. So why do we need this KNN algorithm? Suppose there are two categories, that is category A and say category B. Okay, so here it should be a category A. So, and we have a new data point, let's suppose x1. So this data point will lie in which of this category? So to solve this problem, we need a KNN algorithm. With the help of this KNN, we can easily identify the category of a class of a particular dataset. So consider this diagram. So okay, by considering this diagram, we'll see the steps how your KNN works. So KNN basically can be explained on the basis of this algorithm. That means you have to select the number of k of the neighbors, then you have to calculate the Euclidean distance of the k number of neighbors, then take the k nearest neighbors as per the calculated your Euclidean distance, and among this k neighbors you have to count the number of data points in each category, and you have to assign the new data points to the category for which the number of neighbor is maximum. Then our model becomes ready. Now let's understand with an example where we have some data points of two different classes like this category 1 and category 2. Now our task is to determine the position of this new data point, whether it falls in your red category, that is your category 1, or it falls into your green category, that is your category number 2. Okay, so here where KNN algorithm comes into an action. There are four major steps to perform a complete KNN algorithm. That is, you have to you have to choose the number of k, where k represents the number of neighbors. Then you have to measure the distance of k closest neighbors of the data points, that is this distance we'll discuss. Then you have to count the number of neighbors of each category. Then you have to assign the new data point to the category of most number of neighbors. So now, choosing the distance metric of KNN algorithm. So there are many types of distance metric that have been used in case of your machine learning for calculating this distance. That is, instead of Euclidean distance, you can use another types of distance matrices. So, but Euclidean distance is most widely used distance metric for your KNN. So we'll consider this distance, this Euclidean distance metric in case of this implementation. So now this is yeah, here we have this formula. Euclidean distance is basically the type of distance that we define in case of your geometry. So it measures the distance between two points according to this formula, or by using this formula. So you have x and y, you can calculate easily by using this formula, the Euclidean distance. Okay. Now let's apply the steps on our data and find out the new data point. Now the step 1 here is you have to choose the number of k neighbors. So let's suppose here the k is equals to your 5. So here we take this, okay, just let me write down. So here we have a k that is equals to your 5. Okay, then now the second step is you have to take this k equals to 5 nearest neighbors of a new data point according to your Euclidean distance. Okay, now the third step is among these k neighbors, all these k neighbors, you have to count the members of each category. So here you are counting the members of each category. So now you have to assign the new data point. Suppose this distance is less than distance from red is less than this distance from green. Okay, so now you have to assign the new data point to the category that has most neighbors of the new data point. So here it is a red category. So the distance is less than this distance. So it falls into the red category. So like this. Yeah, but there is no particular way to determine the best value of k. So we need to try some value to find out the best out of them. The most preferred value is for k is 5. A very low value for k, such as k equals to 1 or k equals to 2, can be noisy and lead to the effect of your outliers in the model. Large value for k are good, but it may find some difficulty. There are other methods, that is square root method, hyperparameter tuning, then squads criteria, also one of the method of choosing an optimal value of k in KNN. So now let's begin with the implementation. So here we have again a data set, that is your social media social network advertisement. So first step is to import all essential libraries. So again, we'll just glimpse on this data set. We have a user ID, gender, age, estimated salary, and purchased. We are expecting this graph, and on the basis of this graph, we have to draw a confusion matrix. So let's begin with the implementation part. So yeah, the first step of this KNN is to import all your necessary libraries. So here we have imported the NumPy, your matplotlib and pandas. Then the second step is to import the data set, that is your social network advertisement.csv. So let's look at this data set. Here you can see the age and this estimated salary column. So these columns are your independent variable and this purchased column is your dependent variable. So we will take the age and this estimated salary in the independent variable matrix and the purchased column in the dependent variable matrix. So like this. So we have already implemented. Now we'll split our data set into the training and testing sets like this. So here we put the testing size as 25%, that is 0.25, and random state again 0. So here random state parameter is set to 0 so that the result, and our, that is your result, say your result and our result remain the same. So we need to scale our data set into the training and testing set to make sure that they have a standard difference in between. So here we have imported the standard scaler from this sklearn, and we'll use this and fit the xtrain and the xtest like previously we did. Then the next step, that is here we have using a classifier KNN algorithm. So to do so, we have import a k neighbors classifier from the sklearn library, and here we have created an object that is classifier. Okay, so now we have here we are choosing the value of k is equals to your 5 and your matrix is your Minkowski. Okay, so you can use again here Euclidean distance as well. So after executing this, we'll come to the final result, and we'll do this by using your y_pred, and let's look at the what we'll get. And here you will get the predicted outcome from a model. Okay, now we use the confusion matrix to find out the correct and incorrect predictions. So like this, you will get the training accuracy, that is 91%, and the testing accuracy, that is 93%. Now the last part, or say your fun part and important part of the topic of your KNN is visualization. So we'll visualize the training set results. Is it linear or non-linear? If it is a linear, we get a straight line. If it is a non-linear, we will get a curve shape. So now we'll visualize this. After visualization, so here you can see in the graph, we can see the KNN is a non-linear classifier here. So we won't get a straight line in this case. Okay, now after this, we'll execute a test result code, and we can see that these regions are perfectly fitted to the test observation. We can see the real observation point in the right region. So that's it about your KNN. So this is how you can implement KNN easily by using this k neighbors classifier, and we have setted the value of k, that is equals to your 5. Here you can see any metric instead of Minkowski. Okay, so that's it.
So these are the concepts of machine learning with Python. I hope you are enjoying the videos. Please keep learning, enjoy learning, and please do not forget to press the like button, share with your friends and subscribe the channel. Thank you.